Okay. So good morning. So we'll continue with the lecture, that is valorization of solid side stream, and we'll have a bit of recap. Yeah. Before we start lecture, we will have a practical this afternoon. Yeah. And the schedule will be provided by two volunteers from NIT. And what you'll have to do is you have to observe each and everything. You can take the photographs of it and list all the questions, and we'll go through. It will continue for next 2 days because it's a longer experiments, and we'll have all the questions, whatever you have, we'll go through in lecture session here. Yeah. So your observation is the key. Yeah. It's not just for doing it. It's just to see what is happening and what is forming, and I'll continue explanation over here. Now coming back to this particular lecture on valorization of solid side stream. So first, for recap for yesterday's lectures, we did discuss about what is waste, yeah, how we can reduce it or reform or transform. Yeah. So these are two important elements. Still, before we propose to reduce the waste or to transform the waste, we need to know how much waste is generated and what is the quantity of waste is produced. Then only we can draw down the strategy, and that's the way the policies are made. Yeah. So quick recap for food loss and waste. First thing what you need, this is the crux whatever we discussed yesterday. This is one is action planning. Identify the problems. Yeah. What are the problems? Set objective and KPI. KPI stands for key performance indicators. That means where all you can improve the process. Yeah. Then develop action plan, that is define how you can reduce it. For example, freezing and thawing, how you can reduce it, or you can eliminate the freezing and thawing process to reduce the spoilage. Then you again target how much is produced and how much is wasted, and how we can compare with whatever baseline. So that, because all the policies are made for the future. Yeah, that's one. Then whatever action plan you have made, you implement those actions. It's pretty much straightforward. Monitor the KPI and to see how far you are from your target. It's very similar when you have to prepare for an exam. What all you have to study, how many lectures you will study, what day, and then you implement that plan, and then see how you can further improve that particular action plan. So that's always a live process, and then analyze all the factors which are limiting for achieving those targets. That is, amount of food redistributed or reused, number of food insecure individual, per capita waste generated, or food waste generated per number of meals served. So if you'll go in a canteen and restaurant, it says, there's a figure, it says how much of the food is wasted. Yeah. So we have to clean our house first before solving the global problems, correct? So first you have to see how you reduce your own wastage. In your house, meals are cooked, you ask for 4 idlis, you eat 2 idlis, nalla illa gone to bin. Yeah, right? So if you are correct, then only you can make other people's correct. Yeah. And then generated per kg of product and how you can reduce the wastage. And then again, how much it is a cost, environment benefit, ecological benefit. We have done all those things in different lectures. Yeah. So this is very 3-1. First, action planning, what you should do and where all you can implement the technology, that is application of technology. Second, how you are going to run it through. And third, once it is achieved, to see how effective and how efficient you were. Yeah. You can put anything into this plan. Suppose this is your roadmap for your exams or writing a research paper or for anything. First you set, okay, every week I will study 2 hours every day. Yeah. Your friend calls you for a movie, gone 4 hours. Yeah. So then you improve the plan, you change your plan. Yeah. Okay, let me study in night, not in the morning. Yeah. So like that you make a changes, and then you see how efficient you are, how effective you are, and then you develop your, what are the barriers, or what you need to allocate additional resources to complete that particular action. Yeah? Is it clear in that? This is nothing rocket science. It's just arranging things to make it in a systematic order. I'll give you a very simple example. If you'll see, if there is any flood or tsunami or anything happens, you have seen that always army is called in. Yeah? Why it is so? Do you think army is more efficient compared to civilian police? It's not true. The reason is there is always a process called SOP. Do you know what is SOP stands for? Very good. It's a standard operating procedure. So any work you do, if you create a standing operating procedure, revisit it and improve that standing operating procedure, then you don't have to deviate it. It's not that you have to go in a lab to do experiment. That is called, you know, when you start Havan or Yagya, and then that time you're just missing something. Yeah? So you arrange all the resources, then you plan it, you do a virtual run and then execute it. Take a simple example, you would have attended any of those wedding ceremonies. Yeah? How long does it take to plan a wedding? 6 months, 7 months? Yeah? Execution takes 3-4 hours. Yeah? If planning is not correct, execution will have a problem and there is a point of no return. Yeah? Same thing happens for every work. Yeah? So planning is very, very important. You can take longer to plan. Execution will be very smooth if planning is proper. Yeah? And be prepared for worst case scenario, right? So anything can happen. For instance, we were supposed to start 9:30. There was some repair work going on. There was no cut. So we should have action plan ready. That is plan A, plan B. I'm not talking about the movie plan A, plan B. Yeah. So that's very critical for doing so. Or any experiment, any research work, if you follow the systematic order, something goes wrong, your result is not correct, you can always go back. Yeah. Otherwise, you'll say, oh, I think I added 10 grams. Oh, I think I soaked it here, right? So any deviation you are taking, if you're making a record, then it becomes easier. So that's why document management plan, DMP, is one of the most important aspect of any research work or any work we carry out. Yeah, and that works based on this principle, FAIR. Yeah. I am mentioning this, but this will come back again in lecture number 20 or 22. What FAIR stands for? Whatever notes you are making, yeah, you should be able to find it. Findability, yeah, correct? You are able to find it. A means accessible, yeah. You stored it in a laptop, but you can't access it, yeah. Second important principle. Third, interoperability, that is interpretation. That means whatever you are making short codes or other thing, you should be able to interpret it what you have written. Yeah. Banking sector works in a similar principle. If one accountant is not there, that does not mean you don't know how much money is there in account. Yeah. So that is carried forward whosoever takes the desk. Yeah. So you should be able to interpret that. R means what? Reusability. Yeah. That means should be able to reuse it. Yeah. So data management plan is for FAIR principle. Yeah. Findability, accessibility, interoperability and reusability. Yeah. So this is, just remember that this is one of the most important principle for any data, and if you suggest any other improvement, that can be done. Yeah. Now coming back to actual system. Yesterday I asked a question, what is the difference between protein concentrate, isolate and hydrosolate? Where are the dairy expert or the person who is doing the protein extraction? You, yeah?
Sir, protein isolates are protein made by removing some of the carbohydrate and fats and some non-protein components. It contains about 90% protein. Protein concentrates are the proteins are produced by removing some of the non-protein carbohydrate, but it contains major amount of fats and carbohydrate. It contains about 70 to 80, 60 to 80% protein. And protein hydroxylates are the protein which are made by breaking down some proteins into smaller chain of amino acid by process of hydrolysis.
Okay, and this is, and what will be the protein content of protein hydroxylate?
Near about 80 to 90%. 80 to 90%.
For hydroxylate? For protein hydroxylate? Okay, 80 to 90. How many of you agree with your colleague? He is correct, but yeah, any other addition? Yes?
Sir, hydroxylate can be 50 to 85, 50% to 85.
Okay. Now this is only the target. The question is how you make it, yeah? Protein concentrate or protein rich flour and all those elements, take any biomass, yeah? So if you take, your friend is extracting protein from chickpea flour, yeah? So protein content of chickpea flour is? Okay, I'll put it 22%, right? Yeah? If we remove a carbohydrate, as your colleague mentioned, yeah, 22% this, 60% say for example your carbohydrate, 3 to 4% fat, and similar 3 to 4% ash, right? If you remove a carbohydrate, this 22% will increase to 50 to 60%, yeah? That becomes protein concentrate, yeah? If you further purify it, it becomes protein isolate, which is always above 90%, that is correct there, yeah? Then if you use an enzyme to break the protein, it becomes protein hydroxylate, yeah? So percentage can go almost up to 99% also. Sometimes protein hydroxylates are prepared from protein concentrates or from protein isolates, yeah? Now when it comes to the definition of this, there is no clear cut borderline, yeah? So what we call it protein rich food. Technically anything which contains more than 40% protein will be considered as protein rich food, yeah? Yeah? On what basis? Fish never contains more than 20% protein, but it's a protein rich food. Meat is not having more than 20% protein, but it is not as a protein, but sorry, it's still called as a protein rich food, yeah? So you have to be sure what definitions are. But in the case of dairy, definitions is very clear. What is whey protein isolate, whey protein concentrate, and whey protein hydroxylate, yeah? So these definitions are not the definitions written on the wall that cannot be changed. Does it make sense? Yeah? So some of the protein extraction experiment you will be carrying out on a fish in next 1 or 2 days, even from shells, yeah? So that was the question related to this. And we will cover all these preparation methods and all in coming lectures. How do we isolate protein, how do we concentrate proteins and other elements, yeah? So what is content of today's program? One, what are the solid side stream and what are valorization strategies for solid side stream? So yesterday when we were covering about valorization strategies, about solid stream from different aspects. One was your processing stream, consumer or household is a similar waste, as well as the production side of it, yeah? Now if you take aquaculture, this is a simple aquaculture system, a representative of aquaculture system, whether it's a pond system or IMTA system or as what you described the other day. So what is the assumption moving forward? You saw that statistics, aquaculture is increasing day by day, or every year aquaculture consumption is increasing. So there is a more demand for sustainable seafoods. Consumers are willing to pay more, especially when it comes to European consumer, which is produced sustainably. preference is given more for locally grown food compared to supermarket or bigger brands. A. B. Again, the preference is given to the local growers, local processors, rather than buying in a centralized chain. We are going back slowly to the older one, because earlier you used to have a small shop near your house. You go and make a list and get all the ration and everything, whatever you need for your daily activity. Nowadays you go in a supermarket with a big trolley, pick whatever you want and you come back. Yeah. Now slowly things are going back to the older story, where we has to have like record is there, 1 kg rice, 2 kg this, 100 grams of rice. This is the way it was older time shopping was done. Yeah. Availability of sustainably produced biomass. Yeah. Lack of innovation in aquaculture wastewater. Yeah. So these are some of the assumptions. Then we are looking for valorization. And then the problem, currently there is a aquaculture wastewater as well as aquaculture solid. Yesterday when we were talking about aquaculture, we saw what are the waste we generate in aquaculture production system. Feces, uneaten food. Yeah. So if you remember those strategies when we are talking about lecture number 8. Yeah. Valorization for aquaculture, processing and consumer end. Yeah. So you have to just remember what was discussed other day, because there will be all continuation. Yeah. So it is a base and then we build a block on it. So if you remove any middle block, building will collapse. Yeah. So that is very important to have a full cascading approach. Second one is alternative food and feed based ingredients, that is novel sources of biomass. So what we propose for valorization, one is valorization route for aquaculture wastewater, land based macroalgae production. Yeah. Because macroalgae production needs a sea. Well, what about landlocked cities or landlocked countries? How they can produce macroalgae? So we should have a provision to produce it on land as well. Yeah. Complete biorefinery of macroalgae, new food and food products, new feed formulation, zero waste model for macroalgae, seafood and other streams. Yeah. So this is what we are going to cover in next subsequent lectures along with the technology. So what it will help in achieving sustainability aspect of current aquaculture practices. So it will provide you new improved sustainability current aquaculture practices, new ways of cultivating macroalgae. Yeah. What we'll get? New food and feed, and help environment some way or the other, and ensuring circularity and waste mitigation or minimization. Yeah. So this is what aquaculture stands for, right? Now going back to side stream, we did discuss about this image other day. So what are the solid stream we get from fish? You can read it. Skin, head, tail, what else? Frame, stroke, bones. You can say loudly anyway, because otherwise he'll be carrying the mic everywhere. Yeah. Bones. This is from fish. And whenever such questions are asked, what are the side stream produced? Yeah. Straight away think of the biomass and see what portion is eaten, what is not eaten. Yeah. Rather than doing the guesses, then you miss some of the point. Yeah. So everywhere if you follow a system, it makes things easier. Either you memorize it or you need to know this. So there is always an argument, I did not get a good marks because I can't memorize it. Yeah. But that's not really a valid argument. Yeah. You do memorize who has taken money from you. Yeah. And we tend to forget who has given money to you. Yeah. Not money or any stuff. So you can memorize, you have to understand, then you have to memorize. If medicine doctor say, oh, I can't memorize what is a medicine, what is a dose, I have to give it to you, but I understand what medicine is required. Does it make sense? Yeah. So that's not really a valid argument. If you are really interested in, you will not forget. Yeah. If your only interest is just to clearing the exam or clearing the course, then you won't remember. Yeah. So many times we'll watch a movie and we'll never forget the dialogue. Yeah, lifelong. It's just because our focus is on that one. Brain is having enough of capacity to retain everything. Yeah. Anyway, so in case of fish, head, tail, skin, visceral organ plus your frames and bones. In shells, shellfish, outer shell, attached proteins, all those things will be side stream. In seaweed and duckweed, microalgae, we'll come back to that one. And there also waste is whatever is not consumed. If you consume whole of the carrot, there is no waste. Yeah. Whereas if you peel a carrot to make a carrot halwa, then peel is a waste. Correct? Apple pomace is only waste if you are extracting apple juice. If you are consuming whole apple, then only the seed is a waste. Yeah. So all the waste is depends upon processing strategy. Yeah. So there is not the thing that whole there will be some waste, because some places or certain part of the country, I don't remember exactly, where the whole fish is feeded to some people as a disease or treatment to asthma or something. I've seen. Sorry. Correct. So you just fish is fed it directly.
People. It is actually one transition from the Sankranti.
Sorry, Mike. Yeah.
There is a specific period when there is a transition of sun in the month of June, means the Sankranti to another era. At that particular day, in that particular time, that fish is given.
Okay.
Means there are lakhs of people in Hyderabad.
Okay.
Yes.
So see, this is I heard about it, and that means that's a whole live fish. Yeah. And in some cases, a whole live fish is consumed. That means you are eating its viscera and everything, right? Whatever is inside, the bones and everything is consumed, correct? So that's a whole fish. So there is no waste, correct? But if you are even like a big whale, if it consumes large amount of fish, they do not segregate the stuff, right? They eat everything. Am I correct in saying that? So depending upon what all can be digested based on the waste. So waste is generated based on processing strategy. Yeah. It is not that there will be always a waste. There can be waste, or you can avoid the waste. That's the reduction and this one. But that reduction should not be that, oh, we should not waste it, let's eat everything. Yeah. Then you end up in another problem. So you have all these waste, and then it generates your liquid side stream, which we will cover afterwards, and we'll go through all these extraction technique and what are different value added products can be obtained out of it. Yeah. Now look at this particular diagram back again to the fish. Muscles 15 to 20%, skin, fins and tails, trimmings, viscera, bones, heads. Yeah. So when we are talking in this particular lecture is all about solid side stream plus the biomass. Yeah. This is using better what we already use. This is unlocking the potential of seas and ocean. Yeah. That is what the solid stream, what we are going to cover now, and after that it will continue as liquid food. So we'll just continue with the sequence of lecture. Yeah. So I'll come back to this one again, but do remember what are the wastewater we get out of it. Yeah. Filleting water, stick water, blood, brine, that is if you are using a brine solution, cooking water. If you cook it, if you boil something, there is always a water. If you cook a rice, you separate sometimes rice water. What it contains? Starch. What you use it for in a house? Putting your clothes into it. Yeah. I do remember that used to be what you call that dupatta, like school dress. Yeah. That used to go into that so that it's having a perfect crease. Yeah. Right. What do you call that process? Textile. Starching of the textile. What process is called? It's I know in Hindi it's mard or something is added in, mard, that's basically coming out of the rice, that's a starch, yeah. And even it is used also in, you may not be aware of it, but still all those colleges which goes for government inter colleges and all, I do remember the blue color dress and having a specific uniforms and dupatta. Even my sister used to go there, then they used to do that. So starch is extensively used in textiles. The starch is also used extensively in the paint industry, yeah. So that's one, that is what sometimes you get a cooking water with the protein and other polysaccharides coming into it, or the water which is coming during the drying, that is evaporation losses. So these are some of the liquid side streams. No. Now, if you remember, we did cover this briefly, yeah. So if you have a fish, whether it's a wild harvest or aquaculture, it goes to the industry, yeah. What we do, we make fish fillet, yeah. And this fish fillet is produced and which is consumed. So the losses will be visceral organ, heads, tail, skin, yeah, plus the water is one thing. Other one is a fish cake. That means if the fish is minced, you mince a fish, you mix it with your wheat flour or different ingredient and you make a cake, yeah, and that's called fish cake. Or the same thing like what aloo tikki is made, similar type, potato is also added into the fish to make a fish cake. They are different ingredients, that's all culinary sciences, yeah. Then you have a sausages. That means the same minced fish can be stuffed into a casing. That casing is either made up of intestine lining or is made up of cellulose or made up of different material. You stuff it, you steam it or you ferment it, that's called sausages. Or the fish, you make a sauce of it, yeah. And then or else ready to eat product, fish chips and all those things, yeah. Can any of the fish eater can suggest one or two more products coming out of fish? No? Am I missing any of the product here? To avoid that question, normally I write ready to eat. Everything can be covered into ready to eat, yeah. Other one is ready to prepare, ready to consume, yeah. So all those type of products are made. So in all these processes there is always a side stream, yeah, that's solid side stream. So either we fractionate it, convert it or use a fermentation technology to produce fish protein. Sorry. So how do we obtain fish protein? Mike.
Ask this, like one thing can be included, like in Bengal, the cuisine is we use all the bones and heads of the and as well as the gills to make a dish with the dal that is called mudo ghanto. Means all those things which is going to be the waste, these are added into the dal and it is consumed.
And then bone is digested inside. Then bones are thrown out.
Later it will be something it may be chewed because it softens while the dal is being prepared.
Correct, all the calcium goes into it and that's
Yes,
there, yeah?
yeah.
And then still some of the bones are left. When
Yes,
somebody, if
yes.
you are eating chicken or something, then bones are left,
Yes,
yeah?
sir, yes,
Then a
sir.
boneless chicken and also that's bone, that's
Yes,
again.
yes.
So that means again that side stream comes at domestic level, yeah? Completely agree with all those type of products which will again generate some of the side streams, yeah?
Yes.
That's good. So any other dish? See, he gave an example from Bengal. Any example from Tamil Nadu? Okay, that's fine. So if you see this particular stream, so fish protein extraction, whether you take a whole fish or you take a side stream, yeah, there is a process to produce protein, yeah. will cover in detail of this process once you do the experiment. Yeah, once you do experiment, you'll see how simple it is. Yeah, it is not complicated. We already discussed how we can fractionate lipids and oils, and we'll go into details when we go for valorization for each and every process. Protein hydrosylates and derivatives. Yeah, so that means how you can develop protein hydrosolate by using specific enzymes. Yeah, that is proteolytic enzyme to break the proteins. Then if you have shells, you get chitin and chitosan, or pharmaceutical product in the form of peptides, astaxanthin, or certain small bioactives. Now if you look at this particular stuff, lot of research has already been carried out. So remember this, what TRL stands for? Technology, readiness, level. Yeah, number starts from 1 to 9, and this concept has been adopted from NASA. That was the original concept. That means 1 is when you get some new idea. Yeah, not the cellular connection idea, but normal idea. Oh, this will work. Then 9 is deployment at the commercial level. So that is 1 to 9 scale. So majority of the activities are carried out at 3, 4, 5 and 6 level, and this will come in later on when we try to when we go and look into technology development processes. Yeah, so that is TRL level 1 to 9. Yeah, other one we did discuss about the wastewater, which is not been looked into at the moment. Most of the wastewater goes for conventional wastewater treatment, and after this lecture and the next lecture you will be able to see how we create the value chain and how we can produce microalgae, duckweed, or macroalgae itself on a biomass from the wastewater to generate different chain, and again use the similar techniques to obtain different ingredients. Yeah, so this is the full system, which is a sort of a zero waste approach, which you will try to separate in a cascading manner. The still question is whether we should get protein first, or we should get oil first, or we should get pharmaceutical product first. What should be extracted first? Yeah, that is all the thinking process. You know the technology. Yeah, it is something like what should be the sequence when you get up in the morning. What should be the sequence? You have to take a shower, you have to put on the clothes, and then you have to go to your office. So can you take a shower, or can you put on your new clothes first and then take a shower? Orders. Yeah, similar thing when you are establishing a process, you need to know what should be done first. Yeah, so some of you are doing bachelor's, master's, or a PhD. Yeah, can we do directly PhD and then I will when you get married and all, you have kids, you can do the schooling with your kids? Yeah, not possible, right? So that's why we need to know the sequence and what way to establish a sequence. Yeah, there is no formula for that. There's simple formula: get convinced or convince other person. There's nothing in between. Some cases you can extract oil first. If you do not extract oil first, and if you add an alkali, what will happen? Where is the protein extraction person? If you do not remove oil, and alkali is used for extraction of protein, and if I add alkali directly to the biomass, don't think about the fish, any biomass, the same process, protein is the same. They're all protein are made up of how many amino acid? 36? 22. Can you name it? Yeah? Good one. Yeah.
Tryptophan, tyrosine, phenylalanine, valine, lysine, glycine, and glutamate, aspartate, asparagine, and
good. That's
methionine, proline, and leucine, isoleucine. Just I remember.
Leucine, isoleucine, and all those things, right?
Yes.
So when we were studying, we used to make an abbreviation, MET will
Yes.
fly. Yeah?
Yeah. Sir, I just tried animation for remembering.
That's good. So there are almost 22 amino acids are there.
Yes.
And every protein is made up of those 22 amino acids, right? Basically it's 20 plus there are one or two. One is, have you heard of taurine?
Taurine.
Yeah. Taurine. If you see the Red Bull drink and most of those sports drink, yeah, taurine is present there, yeah. Taurine is not a part of any protein. It's a alone sulfated or sulfur containing amino acid which is mainly found in animal origin products, yeah. And if you isolate it, and this is one of those important ingredient which is used in a lot of different types of drinks, yeah. So that's one of those amino acids. Normally we all know biochemistry says 20 amino acids,
Yes.
yeah. You have essential, you have non-essential amino acids, yeah.
Yes, sir.
So all the proteins are broken down into amino acids. And these amino acids are again used for making protein.
Proteins.
What else? They provide energy as well, yeah. If you remember your NCERT textbook or CBSE textbook, there used to be two figures, one Kwashiorkor and Marasmus, yeah.
Yes.
That is when protein is extracted from the body to produce an energy, yeah. How do we obtain energy in human body? Glycolysis. That means you have a glucose. What's the next stage?
Krebs cycle.
Correct. Within glucose, glucose 1-phosphate,
Glucose
1,6-phosphate,
Yes.
fructose
Fructose 6-phosphate, fructose 1,6-phosphate.
Yeah.
And after that,
Phosphoenol pyruvate is the terminal end to make a pyruvate.
It
Yeah.
is the second last step.
Is a pyruvate, right?
Yes.
Pyruvate is converted to acetyl CoA,
Acetyl-CoA.
and then all this one you have your succinic.
It will
Glutamic?
we go on Krebs cycle, succinate, isocitrate, citrate.
Brilliant.
Yes.
And this one produces NADH, FADH and ATP.
Yes.
That all goes through electron transport chain.
cycle.
NADH gives 3 ATPs. Yeah.
Sir, it depends 2.5 ATP and it's just like FADS to 1 ATP, and sir, NADH will be provide 2 ATP and some cases provide 2.5 ATP. It's depend like sir, we talk about the glucose glycolysis cycle will be produced 32 and in case it will be produced 36. It's depend how much we just like how much we calculate, just like NADPH 2.5 yeah 2 just like ATP.
Brilliant. So that's basically in the broader sense, that is one molecule of glucose will give you around 36 to 38 ATP. This is what is one.
Yes.
Then again, if you go into technicality of it, FADH, NADH, how much ATP it produces. Intention here is when you have a Krebs cycle, some of those amino acids goes directly into the Krebs cycle and starts producing energy. Yeah.
Yes, sir.
That's why we classify amino acid as essential
Essential,
and
non-essential.
non-essential. That means it has to be supplemented from external sources. Because of those presence of essential, non-essential amino acid in external source of food, that dictates whether the protein is of good quality or of bad quality or TEAGASC value and all those biological value. Am I correct in saying that? That's why egg and milk, they contain essential. That's why we classify it as a better source of protein. Yeah. Because pulses are always consumed with the rice or with the chapati, because pulses they lack certain amino acid, whereas exactly lysine or sulfur containing amino acid. So that means our grandfather's father, they were much better nutrition scientists. They knew that pulses should be eaten with the rice. Yeah. Okay. So that's the reason going back. So this will happen in the coming one. We go forward and come back, so that you have how we bridge a gap between your fundamental education, what you already have, and how we develop into processes, right? Now, I can give you one question to find an answer. How much 100 grams of food any food will give you energy in terms of ATP, not kilocalorie. That we all know of this one. You know, we look at the calorific value, oh, it contains 10% fat, 10 into 9, yeah, that is physical form of energy, yeah. Kilocalorie is a physical form of energy, but the biological form of energy is in a form of ATP, yeah. So, if anybody can calculate 100 grams of a food, how many ATPs it will produce, yeah, take any food. We'll put it as 100 grams of, 100 grams of fish, yeah, 15% protein, yeah, 80% moisture and 5% fat. To make life simpler, make it fat, yeah. You all know fat goes through lipid oxidation, it produces your ATP. Protein will go into this, yeah, or even if you change the food product to carbohydrate. I can bet you it will be very, very difficult to get number of ATPs, yeah, because there will be one fundamental principle which we will forget, and I am pretty confident you all will, well, not all, may forget, yeah. Grams, moles, molecules, yeah, that all will come into play into this, yeah. Let's see, we'll see tomorrow if you get an answer, right. Now back to the business. So that's why when I was asking if we add alkali directly without removing lipid, what will happen? Any idea? Saponification, right? Somebody, because that's the way soap is made. Oil, yeah, fat, you add an alkali, you make a soap. And if saponification happens, you cannot separate a protein, yeah. That's why removal of fat becomes an important entity. If you want to make a fish soap, that's different story, yeah. So all those steps depends what will be the potential implication of that particular unit operation, yeah. So any questions so far with this particular diagram? No? Now, so if we go back to the streams, your fish, shells, leftover biomass, seaweed, algae or bycatches. So these are the broader category of biomass what we get, yeah. So what could be the valorization approach? This is again the same stuff in a different form. There are number of different technologies. So yesterday we discussed briefly about cavitation, that is ultrasonics, yeah, pulse electric field, high pressure processing, what else? Cold plasma, this is here, yeah. Ultrasound is done here. Any other technique? Was the breakfast not very good today? SCCO2, yeah, supercritical, or you can have pressurized liquid extraction. There are a lot of different, but the way it sounds looks very complicated, but technically they are very simple techniques, yeah. You work on a simple principle and we get that one separated, yeah. If you have, how many of you use microwave at domestic level? Have you used microwave for heating food? Yeah? Okay. Microwave is one of the most common equipment which is found in almost every kitchen, yeah, to heat a food. But if I put 100 ml of oil in microwave, yeah, and if I put 100 ml of water, yeah, for 1 minute, suppose at 250 watt, just an arbitrary unit, which one will raise the temperature at faster rate? Water. How many of you agree with your friend? Or oil? You agree? Yeah? 3 votes. No, you are not giving vote. Yeah? Why not oil? Whereas oil temperature can go very high. That's it. So that's what it answers. The principle is very, very important, right? Microwave operates at 2 frequencies, yeah? That is 950 and 2450. What is the unit? Megahertz, yeah? Right? Because it's 2.4 gigahertz or 2.4 megahertz, 950 megahertz. Why not other frequencies? In processing, only 2 frequencies are allowed. Other frequencies are left over with our Bengali friend to listen to radio FM, yeah? You know, when you tune in the radio, it says this much megahertz and all, right? So other frequencies are used for communication, other purposes, yeah? So what does 950 means? That means polarity is changing 950 into 10 to the power 6 per second, yeah? Right? So if there is a water molecule, what is the structure of water? Very good. This is the easiest structure what we all studied all the time, right? Now, what's the angle? 109. Yeah, 109 or 108 point something, right? But that's immaterial anyway for this particular purpose. That's correct, yeah? Now, when we change the orientation, plus minus, it moves very fast. This finger temperature may be around 20 degrees Celsius outside. This is again 20. If we rub it, temperature finger increases, temperature of this increases, yeah? If I rub with the speed of 950 into 10 to the power 6, what will happen? It will heat up very fast, yeah? Now we make a twist to it. If I add 1 gram of salt to it, so it will heat even faster, yeah? Because we are adding Na plus and chlorides, yeah? So that is why, okay, not that is why, but other day somebody suggested that if we give a microwave treatment, we can have a better oil extraction. So that statement is correct or wrong? Don't worry, I am with you anyway, yeah? Loud, 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 yeah? Quick. That is correct, because there we are not heating the oil, we are heating whole of the biomass, yeah? Which contains protein, water, salt and all those minerals. They heat up, yeah? When they heat up, it separates the oil out of it, yeah? So the microwave extraction is more towards the thermal side of it rather than microwave on its own, yeah? So I'll go through with these technologies in, I don't know the lecture number, but by coming days we'll have all those technology. So that it does not sound something out of blue, out of moon, that's why I'm just giving some brief touch up with the technology so that things becomes easier and it won't be a monotonous communication, yeah? So any of those technology, key ingredients we can obtain is protein, oils, fatty acid, chitin and chitosan. I wrote it omega oils because that's the way things are sold in a market. So oil and difference between oil and fatty acid, you should be very clear again. What is lipid? What is oil? Yeah. What is fat? And what is fatty acids? Yeah. So my eyes are very good with these glasses. So whosoever is skipping, I am going to ask only them the question moving forward, yeah? Or whosoever is having very nice jokes on their phones, yeah? So that's, you remember what is the difference, how we can make a fatty acid out of oil, yeah? It is not that we can only make it from fish. We can also make the same quality of good fatty acid from your chickpea, almond oil, argan oil, all those ones, or even normal vegetable oil. That means to remove glycerol. Enzyme used for that is lipase, yeah? And what is lyase? Joints, yeah? Lipase, ligases, yeah? Ligases, lipases. Yeah, go, yeah, correct.
Yeah. So just like in DNA replication, DNA ligase just add to nucleotides
Okay.
with the help of NADH, right? No, sorry, NAD. It converts.
That means you need a catalyst to do that,
Yes,
right?
sir.
Yeah. So that is, one is for breaking, one is for adding, yeah? There is a group of enzymes, proteases to break the proteins, yeah? Right? So that's the way how you can see how your previous one helps in developing an extraction system. So you need not to be a chemical engineer or a mechanical engineer to understand the technology, yeah? So that's why food science should have all those knowledge, or at least the basic one, so that you can develop your own processes, yeah? Now, solid side stream, shellfish again, we saw the fish one, and then shellfish, head, tail, cephalothorax. Zoologists will say, what is cephalothorax? Something called hexapoda, yeah, right? When you have head and thorax together, cephalothorax, yeah? Hexapoda means not the Tamil poda, poda means go, right? Hexa means 6 legs, yeah? So anyway, all those animals, yeah? So we use different technique, that is enzyme assisted extraction, ultrasound assisted, that means the technologies are added, pulse electric field assisted. So here electric field is given in a pulse mode, yeah? HPAE, HP, high pressure processing or high hydrostatic pressure processing. Well, both the same thing, the terminology difference. And supercritical fluid extraction. What is APP? When there is high pressure processing, another one is atmospheric pressure processing. That means done it in natural environment, yeah? So don't get bogged down with these abbreviations. Sometimes scientists, including us, we have a tendency to complicate things, yeah? That's why it says, कहना क्या चाहते हो? That means what do you want to really say, yeah? Right? So that's one. And all these techniques can be used for protein, lipids, chitin, chitosan, astaxanthin and other compound. Now, what other, when it mean by other compound, we did cover briefly protein, lipids, chitin, astaxanthin, what other compounds? Yeah? Sorry, Mike, yeah.
Sir, pigment, just carotenoids.
Carotenoids, okay. Will astaxanthin not be called as carotenoids?
Sir, it's a type of pigment.
True. That's correct, yeah. Carotenoids from microalgae as well as macroalgae.
Yes.
Yeah. Any other compound?
Sir, any other compound? Like,
Yeah.
sir, like lipid, carbohydrate, proteins.
These are done. Other compounds, yeah. Some are even peptides are there.
Yes.
Other compounds, that means all those minor constituents which can be obtained, yeah. That's right, you have minerals, you have vitamins.
Yes.
Vitamin is not written. What are vitamins? They are vital amines, correct? That's the way name came in. And some of those are small minor carbohydrates are there. What is basically a carbohydrate?
No, it's a monomer.
No, define this word.
It's basically made from carbon, hydrogen, oxygen.
So that means hydrates of carbon
Yes.
becomes carbohydrate. So if you have black coal, yeah, this carbon,
Yes.
you have water, you add a water, it becomes carbohydrate, yeah,
Yes.
essentially, right? But that means if you are overheating a product, what happens? It becomes black. Am I correct in saying that? So basic formula of carbohydrate is CH2O
N whole.
N,
Yes.
right? If it is 6, it becomes glucose, yeah?
Yes.
So only nature is having that power to take the carbon and with the water to make carbohydrates, yeah? So we cannot add water to the carbon to make carbohydrates, yeah? So why I am mentioning this here, when we estimate a moisture, we say suppose it contains 10% moisture, yeah? Why these elements are very, very important in order to establish a biorefinery to see what is the mass balance. If there is 100 kg of product, so you should be able to get 100 kgs of different substances. In inaugural address, when Professor Panda was mentioning the efficiency is only 30-35%, yeah? Other things are gone as a waste. And you know, first law of thermodynamics, second law of thermodynamics, nothing can be created, nothing can be destroyed. We can only change the forms, yeah? So when we estimate a moisture, this is one of the limitations why a lot of mass balances, they go wrong. Because biomass, if it contains 20% moisture, you get an ingredient which contains 5% moisture, yeah? So when we say moisture content, what does it really means? Is it total water content?
Unbounded means surface पर जो पानी होता है उसको.
Correct. That is basically the 3 different types of water are there, right? One is free water, bound water and okay, what free in the water is, that's fine, it's present in the cells, yeah? What is unbound water? So see, it's good that we know all those terminologies and what is it. But if you have an apple in a hand, if you squeeze it fully, you get your free water, yeah? Then what will be a bound water, what will be unbound water? Yeah? You have to repeat it again, sorry.
Okay.
Yeah.
Bound water is the water attached to the chemical constituents of the food, which can be separated during the drying process or any other processes. But the third category of water, I don't remember the name, that cannot be separated from the component.
It can be separated, but you will be left over with the carbon. This is called bound water. Yeah?
Yes.
The 3 water, one is free water, and we normally estimate the free water as a moisture estimation. So there is an AOCS method or AOAC method, 105 degrees Celsius for 24 hours, yeah? Then you keep it into a vessel to determine the moisture A, or else 121 degrees Celsius for 1 hour, yeah? That is for grains. For oils is a Karl-Fischer titration, yeah? All those who are doing masters, they will be pretty much very clear about this. Proximate composition and ultimate composition, yeah? When it comes to sugars and chocolates, we cannot use such temperature. We use vacuum oven method, because if you use 121 degrees Celsius or if you use 105 degrees Celsius, all the sugars will be broken down and you report it in terms of fat content, or sorry, moisture content, yeah? So the bound water, unbound water is basically water between the fibers attached with van der Waals forces, any fiber which absorbs the water between the molecules. One protein molecule with lipid, lipid with lipid, or protein lipid, that's all is bound water sorry, unbound water, free water and bound water, right? When we get rid of bound water, only carbon is left. That's why when we overcook bread or a chapati, it becomes black. That means that bound water is gone. We are only left with the carbon. When we get rid of carbon also, then what is left? Ash. That is basically a mineral, yeah? And that contains all your iron and everything there, yeah? So that's the way how it works. So that all decides how we can get this. And another important minerals what we can get out of this is your selenium, yeah? When you buy those mineral bottles, you know, like it contains good amount of minerals, from where they come in, yeah? All these sources, heavy metals and everything will come into ash, yeah? And then you have your feed additive, fertilizer, pharmaceuticals, packaging, cosmetics and different ingredients. All these ones can have different applications, yeah? So you have 3 or 4 challenges being a food scientist or a food engineer, or whatever you want to call yourself. Biomass, how we process it to get ingredients. Once you have ingredient, what you do with that, yeah? First you need to earn the money. You earn the money. What you do with that money? You bought a car, then you bought a car, what to do with that, yeah? So there is always a challenge, it's not only in this case, yeah? So that's one, and we'll go with the shrimp shells now. Harvesting, storage and frozen. One thing is good, lot of things some of you have already covered, so it makes things much easier for me, right? Shells, harvesting, thawing and washing, peeling, cooking, and goes to market, yeah? This is all is a part of the big project we're talking about, impress-he.eu, yeah? You can go to the website, you can have a look, all those update, and this will running till 2027, and all those commercial processes, how they are being transferred, not in the lab alone, at the pilot scale to the commercial, and commercial to the business running, yeah? This stands for 6.8 million euros, and it's a big money, yeah? And only focusing on blue circular economy. So there are almost 80 plus researchers across Europe are working on this one, yeah? These are big projects, something like what you see, big project for establishing, you know, factory or a biorefinery and all those. And based on these outputs of this, whatever value chains are created, then the factories are established, yeah? We'll see some of the example in coming stuff. So wastewater generated 8.5 liter per kg, yeah? Rough estimations, yeah? That will vary depending upon your processes. Wastewater 1 liter per kg depending upon the cooking process, yeah? That means you have shrimp shells, you wash it, clean it, put in a water and you cook it, yeah? It's something like when you cook a rice, yeah? If you have 100 grams of rice, and how much water you add in a rice? With this finger? Yeah? I only know this whenever my mother used to ask to make a rice, she'll say put the water till this one. I never understood that unit, but that works always perfectly, yeah? So that means if you are adding 1:5 or 1:6 ratio or 1:10 ratio, yeah? You cook it, and this is again optimized so that you don't have amount of wastewater generated, and in that process shrimp shells 600 grams per kg, 75% of moisture, you dry it, mill it, demineralize, deproteinize, acetylation, and this is what you are going to start doing the experiment today, yeah? So now next time when we are coming in a lecture, you are going to tell me what does it all means, yeah? And how do we achieve this, yeah? Shells, you dry it, and you all are lucky that some of researchers from NIT, they are not here at the moment, they have already dried those shells for you, yeah? And then you grind it, you demineralize it, that means you use a technique to remove the minerals from there. The shells are hard like a stone, but you remove the minerals. Then what will be left is a protein and chitin. Then you separate the protein. Then you are left over with the chitin. and that chitin is converted into chitosan, which is sold in a market. Yeah. So shells are waste, they just throw it in a bin, and from the same shell you make a chitosan. What is the cost of chitosan? Any idea? When you are doing experiment, ask those questions. Yeah, they all know those. Yeah, and this chitosan is also used to make biodegradable packaging material. They are also antimicrobial. They use in agriculture application as a fertilizer as well as biopesticide or biofertilizer. Yeah, and these extractions can also be done by ultrasound, microwave, combination, fermentation and enzymes. So what you will be doing is only the basic part of it, then it is left on to you how and where you can use those technology. This will be covering in theory. Yeah, and each and every topic will have a PhD topic on its own, like your friend is working on thermosonication of milk. Yeah, so that again itself is a full thesis topic. Yeah, now and then you have your chitin. So if you start with a kg, you can get up to 45 grams per kg of wet shells. Yeah, so these are all goes with the economics and economic assessment. So what are the side stream we get? Protein rich water, mineral rich water, yeah, and alkaline water. Yeah, and this will give you mineral. What is a calcium? Source of calcium. Yeah, and then this will give you the protein, and this shell protein is having strong bioactivity. If it is converted to peptide, it is having lot of bone healing properties. Yeah, and then alkaline system. So this is what we can get, all those ingredients. And you mentioned about the pigments, carotenoids, and you get it from shrimp, that yellowish color pigment, which is again having a biological activity. Yeah, and then this is some of the calculation. You don't have to worry about numbers. 5.6 tons of shrimp shells generated. This is for a specific country. I won't name it here now. Yeah, because certain informations are bit confidential as well. And then this much cubic meter. So who is good engineer here? 1 cubic meter means how many liters? Or 1 liter is equal to how many centimeter cube? That should be like this, 5 tens are 50, like that. Yeah. So 1 ml is equal to 1 centimeter cube, right? That means 1 centimeter by 1 centimeter cube, you can put only 1 ml of water, provided the density is 1. Yeah, 1 kg per liter. Oil, that is volume and density. You don't agree? Yeah. So if you see 5.6 ton, that is 53.2 metric cube of water is used. This is the amount of the wastewater which is generated. Yeah. This many tons of shrimp shells, this many kgs of your 840,000 tons of dried shells, and how much chitosan you can produce. Yeah, and if 1 kg of shell of chitosan costs around 5,000 rupees or 6,000, I know in terms of euros, crude chitosan we get around 100 euros for a kg or something. So you can think of how much is the value which is going into the bins. Yeah, and this is not a rocket science to produce a chitosan. It's been done since for last 50-60 years, right? So only to take it and make a business case. Yeah, total side streams generated. Yeah. So this is one of the example of shells, and we'll take a break, and what we have covered so far is all your side streams and given a specific case of shrimp shells, how we can get into chitin, chitosan, and when we come back, we'll go through again with liquid and bit of solid together, yeah, because both are produced hand in hand. So that means if you are extracting chitosan, there is again a water which is produced, how we can valorize it, yeah. It is something like heat can be extracted, you use electricity to light bulb, bulb produces a heat, can we extract that heat, yeah. So that's like again where do we stop it, yeah. So with this we conclude and we'll come back in 10 minutes, yeah, or 15 minutes. Okay, so we'll move on to the liquid side streams, yeah, and before we go on to liquid side stream, I'll just quickly recap what we did in a previous one was on solid side stream. You saw the example from shrimp shells, yeah. So recap, we take it with the crab shell. So similar story with the crabs, yeah, shrimp and the crab. How many of you know what is a crab? Kekada. Yeah. So there are a number of different types of crabs are there, right? Blue crab, spider crab, number of different types of crabs of different sizes. So again, if you'll see, normally it's primary process, final product for direct commercial sale. This is one way it is sold directly. After cleaning and killing, or sometimes live crabs are sold, yeah. In certain countries, and live crabs are cooked live, yeah. Like what it happens in Nurk, you know, you have to fry, you will be fried in hot oil. Same way some crabs are cooked live to have a better taste and better whatever, yeah. So, or else some of those dead crabs or damaged crabs which cannot be sold directly goes for animal feed, or unsaleable crab, this is another problem, and the processed crab into crab meat, another one, they generate your shells and other products, yeah. So crab byproducts are completely different as what a shrimp is, yeah. So again, what you do is whatever is unsellable crabs, that is again the whole crab is sold with the claws and everything, a leg is broken, a hand is broken, that is people they do not prefer because it looks like incomplete one. So those ones goes for recovering the meat either for food purpose, feed purpose, or for pet food, and then you have a meat, frozen, pasteurized or canned meat, yeah. These are the processed product. Same way you have ingredients which can be used for making paste, pate, snacks or cakes, a number of different products. This again goes to food science and nutrition science or product development or whatever you want to call it as, yeah. Now when it comes to leftover shells from here, it's a very good source of chitin, chitosan, yeah. Every shell does not contain a chitin, that you will figure it out when you do the experiment in 3 different matrices. So shells and harder part, you have minerals, you get proteins, enzymes and other bioactives including chitosan or polysaccharide, that is chitosan, or pigments or crab flavor, you know, you can get all those liquid extract which will act as a stock solution or a flavoring solution, yeah. And if you will see this many amount of this much amount of million tons or metric tons of crabs are left unsold because of different issues. I'll give you an example. Oversized, undersized potato. You go and buy potatoes. You don't worry about everything is small or big. You just buy it, yeah. But in Europe, in certain countries including Ireland, oversized and undersized potato is a waste, yeah. People would like to buy a potato which are of uniform size, yeah. Big potatoes, very big potatoes goes to McDonald's and other places to make French fries, and some oversized, undersized potato which are graded are dumped as a waste, yeah. And that waste, to valorize it, now goes for starch production, and there again you have different waste. So, waste depends upon what is the consumer requirement, yeah. That is why it says here unsaleable crabs, yeah. Nobody eats those claws and hands, yeah, they only eat the meat in it. The leg is not there, but at least rest of the body is there, yeah. So, they prefer to have intact crab to be purchased of premium price. So, that depends how the processing is happening. So, within this again the same process applies to obtain chitosan, yeah. This is the practical what you will be carrying forward, yeah. So, whatever we get here is again the wastewater, which can be used again for recovery of protein, minerals and pigments. Once you recover this either by membrane or certain technique, leftover water can be used for duckweed cultivation, microalgae cultivation or even macroalgae cultivation. So, that water can be used or it goes for wastewater treatment. So, whelk shells, we already did discuss about the shrimp and a crab. Similar thing works for whelk. What is a whelk? Is snails, yeah. What do you call that snails in a local language? Ghonga, I know the ghonga, yeah. So, that is same type of shells, exactly same thing, whole of the snails washed, cleaned, cooked in a water, meat is recovered, shell is a waste, yeah. And then there also you get a wastewater, yeah. And then this is some bit of statistics. So, if you have 400,000, that is 4 lakhs, yeah, 1000 tons of whelk are processed, 80,000 kg of meat is obtained and 320 kg, 320,000, that means 3 lakhs 20,000, yeah. When I say 100,000, that means 1 lakh, yeah. It is just because different units, million, billions, 100,000, we use lakh, crore, but that is 1 crore is 10 million, yeah, like that type of conversion. So, 320,000 tons of shells, protein extraction by using enzymes, yeah. You can get 3.2 million tons of water with protein rich fraction, that is 0.5 grams per liter, right. That is 0.05% of protein in that particular wastewater. So, that is goes as a waste and you have dried shells, yeah. Now, if you see, this is what statistics comes from the industry when they are processing it. So, that is the problem what you have. So, if you have this much amount of water in a year having this much amount of protein, what you can do with that protein? Send this water to wastewater treatment or else recover this protein. How we can recover this protein? Either by isoelectric precipitation, that is by adjusting the pH A, B by A is by precipitation, B is by drying all the water to get that protein, yeah. C step is to use a membrane, that is like reverse osmosis, ultrafiltration, nanofiltration, use a membrane to trap that protein and get the clear water, yeah. And that clear water still will contain certain amino acids, broken proteins, another one, that means nitrogen, phosphorus, certain nutrients are there. That water can be used to grow duckweed or a microalgae, yeah. You create a new biomass and then water can be discharged, yeah. Or D step is to send all this water to wastewater treatment, yeah. Your 4 different options are there. Yeah, that's the way we establish circularity. That's the problem given here. Yeah, what way you use this particular water. Remember, when if you take a milk, yeah, 1 liter of milk will produce how much amount of cheese or paneer, dairy? 150 grams of cheese. Yeah. So 1 liter makes 150 grams. What is leftover whey? Whey means leftover water. Wait 1 second.
750 grams.
750 grams. Take it 750 or 600 grams of of water is left over. Yeah. That 750 ml of water contains some amount of protein in terms of 1% or 1.5%. Yeah. And that particular protein is, that liquid is known as whey. Yeah. And that particular whey protein isolate is sold in a market. Yeah. Think if we are talking about that much amount of solid, which is 1% or 2% or 0.5% solid, why we do not use this particular protein to be recovered from mussels and shells, yeah, even though the volume is high. Yeah, you don't have to set up €1,000,000 business to have tons of whey. You can have only for this particular sector, or even for a small processor who is processing 1000 kg per day or 1000 kg per week of a crab. Amount of water it is producing is dumping it. You have to put simple membrane system to recover the protein, dry it, and you sell it as a soup mix or make an ingredient out of it. Yeah. Those who like fish, they also like salmon fish flavor, yeah, or crab or whelk. So this is the way how we can take translational approach. That means learning from dairy sector into this. Do you all agree with that? Yeah. So this is the way we can recover value out of waste. It's not only just talking about waste to value, apple pomace to pectin and some of the streams. That's the reason I am picking up those examples which are easy to achieve and can be developed into. Yeah. So once we have this, you can recover both lipids and a protein and water for duckweed cultivation. And this water for duckweed cultivation can also be used for cultivation of microalgae or any other biomass. Yeah. So that is way we can obtain high value ingredients, and the lipids over here, they are always non-fatty or polyunsaturated fatty acid, although that will be in very small amount. Yeah. So that's the way we can convert those liquid processes. Now, so water, how important is the water for food? If you see, water between 2000 to 5000 liter is needed for everybody's food intake. Yeah. So this is roughly amount of water. This is not per day, obviously. Yeah, amount of water required per day per person, and amount of fresh water is limited, and you need water for irrigation, livestock, application of your pesticide, washing, cooling, refreshing ingredients. Yeah. So do you know how much water you use in every day? So there is, if you calculate it, number of times you go to toilet, number of times you turn on a flush. One flush, there is a regulation. Yeah, is 20 liter. The smaller one, if you press, the bigger one is normally 20 liters and smaller one is 40 liter, because people, they have a tendency to press always the bigger one if there are two switches. So always bigger one is 20 liter and smaller one is 40 liter. But over here, some of those tanks are 80 liters and 120 liters. Yeah. So that is one of the water usage. A. B. Drinking water is less, 3 to 5 liters. Water required for bathing and other things. Yeah. So water is required at every stage. Yeah. Correct. So that's water is very critical for sustainable food system. So we have to get a new way of water, either taking from ocean by desalination and all those processes, or try to restrict the usage of water in food processing operations, or to valorize the wastewater or processed water which is coming out of the food processing stream. Yeah. So, you will see two words interchangeably used, that is processed water and a wastewater. By processed water, what I mean in the subsequent sections is the water which is used to process the food, washing of fillets, using the water to extract the protein, that all will be processed water, that is all potable water. Wash water, washing of the floors and other one of the industry premises, that is a wastewater. Yeah. Now, so how we can make use of the water, how we can reduce the water usage? One is changing the production system. Yeah. And if water is not dealt with, we have changes in temperature, extreme weather events, and we need to have reusing of organic waste stream or wastewater treatment or water treatment options. Yeah. So, this is what water scarcity is going to be a major factor in most of the country. Yeah. Because of changes in climate, undue rain and a flood. I am not going to go into that one, just giving the importance of water in daily life, food production, food processing and different unit operations. Yeah. So, if you see what is the type of water required for food production. Yeah. So, when I said about we are going to valorize the nutrient from the wastewater or a processed water, at the end whatever water we are getting after production of duckweed, microalgae or a seaweed, can we reuse that water into food processing system or in the food consumption scenario, or we can dump it into river. So, this is all to do with the guidance note. If you go into FSAI, that is Food Safety Authority of Ireland, same way FSSAI is there for India. They have clear cut demarcation, what is a potable water, what is drinking water, what is wastewater, what is strong water. Have you heard of this word called strong water? Rainwater quality, and all those water quality for different application is very well specified. So, important one is from where the water is coming in, farming, runoff, grazing livestock into waterways. That means all the slurry of animals goes into the water, that means all the nitrogen is going into the river streams. Industry effluent discharged into waterway, all those factories are situated around the river, they dump their wastewater into river. Yeah. Urban wastewater treatment plant, effluent, private septic tank, badly constructed, leaking septic tanks, all these are the sources of water contamination into the groundwater. Livestock, pets, wild animal, access to the water sources. Yeah. So, we do get our bottled water like this, but animals and pets, they have to go and take the water from river. Yeah. And the same animal is eaten. So, if they are drinking contaminated water, or if you are harvesting the fish from the river for food purpose and you are contaminating the same river, so what will happen? You are getting your own nutrient contamination back to your body. Jaisi karni, waisi bharni. Yeah, right? Simple. That's not. There is no rocket science there. If there is a meat processing plant, they use all this chlorinated water dumping into the sea, and they are harvesting the same fish. So, that is the circular economy of the contaminant for that same population. Yeah. So, that is important thing to understand. So, again on farm practices, storage of farm manure, slurry, soil amendment, disposal of pesticides, collection, storage and distribution of rainwater, nature private wells, and all these things are one which contaminate water apart from food processing operations or agri-food operations, how they are changing. So, this is what when you assess the risk of water contamination. Yeah. So, this is an important aspect to understand the requirement of water for food processing operations or for potable water, and how we can assess risk. Yeah. Now, so what are the water treatment options? How we can treat the water? Simple one is adding the chlorine. Yeah. Chlorination is done at a treatment point at very high concentration. By the time it reaches at domestic level, water chlorine level is low. So, we are consuming lot of chlorine as a form of water treatment. So, you have coagulation, flocculation, sedimentation, filtration, disinfection using chlorine, chlorine dioxide, ozone or UV light. Yeah, these all are treatment system for water. I am not again going to go into that part, and the similar approach can also be used to treat the water whichever is left over from the food processing operations, so that that water can be reused within the same industry premises, or the processed water which is used extensively can be used for cleaning of the water, right. There is a potable water is required, and if the water is of not that standard quality which can be discharged into the river, or that water can be used for the cleaning purposes. Some of those standard practices are smart designs. That means whatever you have your flush, that is always linked with your wash basin. So, water is collected there with the filtration, that means only solid is going away, right. So, why always to have a fresh water for your wash basin and the same fresh water for flushing water? Make sense? Yeah. So, that all every small changes makes lot of difference. There used to be old advertisement, what is called boond boond bachana hai, yeah, right. Do you know about that advertisement? There used to be advertisement like you have to save every drop of water like this, yeah. So, safety and a quality of water used for fresh fruits and vegetable, yeah. So, that will give you all the guidelines. This is again, as you see the table 2 coming in from this particular document, and whatever is referenced in any of this presentation is freely available. That means either the papers are open access or they are in FAO document which is universally adopted. I am not focusing entirely only on a country specific or European document, but pretty much the regulations are similar, yeah, okay. So, that is what it says: pre-treatment, coagulation, different water treatment system. I'll propose one way. If you are using a brine, yeah, and we can reuse this brine by using a membrane system to recover all the solid, even the simple filtration system, and then use any of these techniques to decontaminate that brine and reuse that brine, yeah. That is the way it can be used. If you know some of those people who make paneer at home, whatever water is left over after using tartaric acid or your citric acid or lemon or whatever, the same water can be used again for next stage of curdling process. But at house is okay, you have plenty of lemon, but you are talking about the quantity, that makes things easier, yeah. So, that is way how we can reuse it. So, the crux of this is all to do with innovation, yeah, that is innovative idea to use it. Now, process water valorization. We started with aquaculture for solid stream. Similar thing is aquaculture production. Whatever wastewater is there in aquaculture which is happening in the sea or in a pond system, if we can use the same water for growth of macroalgae, yeah. This is macroalgae, that is Escargopsis, and if you look at this particular species, this is one of the important species which has been seen as reduction of methane emissions in cow. Have you seen when there is a big bloating in cow, you have to put a syringe so that all the methane comes out of a cow, yeah, because that is a huge impact on animal intensive agriculture, where methane emission coming from bovine animals is contributing to methane in environment, yeah. So, this is used as a feed additive because of bromoform, yeah, which is added as an animal diet to reduce the methane emission from bovine animals. Or vulva, that is again a green seaweed which is good source of protein to recover the nutrient from wastewater. Or similar one can be used for duckweed. The only example here macroalgae is given because this particular water is from marine source and these seaweeds grow only in marine environment, yeah. Duckweed is mainly fresh water and some are salt tolerant. So, there is again species selection is. Then we have new technologies or different type of processing approach to create a value chain for feed or a food, leftover biomass for energy. Yeah. This is one is a blueprint how we can use processed water for valorization. Yeah. Then another technique, if you see coming back to the fish, once aquaculture fish is processed, you have a whole fish. This is pretty much the process line for fish. Yeah. Your whole fish, you wash it, you freeze it, you thaw it, you do filleting and you get your food product, right. Simple process. Or else you have a whole fish, you can put any species, mackerel this line, salmon this line, sardines, tuna this line. Yeah. Fish is washed, you put in a brine solution, you steam it, you put in a can and you get your protein rich food. Yeah. So, this is what I have written as a protein rich food because fish is considered as good source of protein. Now, what happened this process? The water coming out, the whole fish when you are washing it, you have all your mud and everything on top of the fish. Yeah. That is called stick water. That is mud water, another thing. Washing of the fillet, you have wash water. Yeah. And water used here is a potable water. You are using a brine, then you have leftover brine or you have waste water along with the steam. When you steam the fish, the water collected that also solubilize some of the protein. So, this is the estimates which can contain, if you are using 5% salt as a brine solution, you can have 10 to 12% protein in that particular water. If you are using a steam, 5 to 8%, if you are using only water, you get only 1 to 3% protein. Yeah. These values can vary depending upon your intensity and the process. You are making a thick fillet, this may be less. If you are making a thinner, wafer thin fillets, then it is a different story. Yeah. So, that will be just rough estimates. Yeah. And if this particular water, this is just representation of the water which was collected from the wash factory, use a membrane, you spray dry it or you freeze dry, you get your protein. Yeah. Simple process, you do not need to know about rocket science to develop this process. Yeah. Stick water, high amount of BOD, COD because muds and sludge and everything that goes for wastewater treatment can go as usual as a wastewater treatment. If you mix this water with this water, then story is different, then you cannot use this as a food ingredient. Yeah. Whereas, this is a process water and this is wastewater. Yeah. And then if you see ultrafiltration, salt brine, ultrafiltration, retentate and permeate, that is something like when you are saving, you have retentate and a permeate, two fractions, and amount of protein distributed in different fractions. That means, if you are using ultrafiltration at molecular level, normal brine solution if it contains 10.6 milligram per ml, ultrafiltration or 100% and then 90% protein can be recovered by using ultrafiltration itself. That goes straight for spray drying, you get a protein. And a rough estimate is every 100 kg of sardines, we need how many meter cube of water, yeah, and how many meter cubes of cubic meter of water is used and what is the protein content you can obtain from that water and lipids. Think of the volume of several thousand tons of fish processed globally. Even if you take a specific district, take it even Cuttack in Odisha or Calcutta, or if you take it in Chennai, Kanyakumari or Kerala, any of those districts, within that place itself amount of fish is processed and amount of water it will generate and what is happening to it. Yeah. So, we can consider the business case and how economical it will be. Yeah. Now, this is another one, fish processing plant different wash water. This is having more specific details. Previous one was on a bigger figure, and as scientists they have a tendency to complicate things, so this I have a bit complicated with what you get out of it. Yeah. Fish processing operations and fish value added product. You have nitrate, nitrites, ammonia, lipids, nutrient, phosphoric acid, nitric acid, other contaminant, all this effluent. If you try to check the composition of the process wastewater or process water or wastewater, you have total nitrates, total phosphorus, total potassium in different forms, you get it, right. If you have seen the water report, nitrate, nitrite, phosphate, everything out of it. Yeah. Wastewater with high level content of blood and contaminants, wastewater with less amount of blood depending upon what type of fish is processed, or wastewater with contaminant. So, before you start valorization strategy for a wastewater, you need to understand what are the contaminants in a water, what is the condition of that water before you start extracting. Yeah. And then all these nutrients, whatever is there, then you decide whether you want to propose a system to grow macroalgae, microalgae, duckweed, or any other plant which can absorb these nutrient at what rate. Yeah. It is not that since I said you grow duckweed that you only grow duckweed. You can go for microalgae or you can go for other plant, that is biological way of remediation, and then phyto, that is plants for remediating wastewater, is one of those microalgae, because microalgae have a tendency to grow on high nitrogen, low nitrogen, high phosphorus, low CO2, high CO2 or different oxygen, that depends upon the species. Then you harvest your cells and you get your different nutrient. The crux of this particular flow diagram is to use inorganic nutrients into organic. Yeah. Because if you, from where we get these acids, because certain processes, you know, when you are using chlorinated compound, acid extraction, or this also include, you know, extraction processes. When you are going to extract the protein from fish or from chitosan from shells, you will be using acids and alkali, that will be altering the pH. Accordingly, you can select what biomass to grow. So, we already discussed this one in day 1, conventional wastewater treatment system, right. All the wastewater, this is the image of that, it is energy intensive, huge amount of resources are required, and then the issues with sludge removal, right. Now, if you look at this proposed solution, yeah. Now, when you see this word phyto towel, this was a team of 2 master's student and a PhD and 1 final year undergrad student. They came up with one of the idea to use the wastewater valorization, that is added in next couple of slides. The proposed model was, because soya bean is imported as a protein from Latin America and it is having huge amount of issues with the climate and other things, because Europe or certain countries cannot produce soya protein which is used for animal feed. Yeah. And then the wastewater coming from dairy is mainly nutrient rich. Yeah. And I can say this specific example of dairy was added because lot of dairy technologists were coming in here as well. Yeah. And then you have dairy processing plant, this wastewater, this is the proposed phyto towel, that means to grow duckweed. You get a clean water, you get a biomass which will be covering in duckweed production, you will see how it is cultivated. You dry it and this is the best source of protein which can be used for the same animal which is producing that wastewater. Yeah. Does it make sense, or any questions you have? It looks so rosy, you know, to draw the process on a paper. When you start doing it, then its problem starts. Yeah. So, this is one of the project called duck feed. That means how we use the wastewater from different sector to produce duckweed, and if you'll see different species, Wolffia, yeah, origin which country, that means doubling time 1.3, that means if today biomass is 10 grams, in 1.3 days the biomass will become 20 grams, yeah. So, and this is the composition of dairy processing wastewater, high amount of BOD, COD, and the water to be discharged in a river is having a limit. You cannot discharge the water having more than 100 BOD or COD, yeah. So, you do not have to completely eliminate all the organic matter, you can partially eliminate the matter, and this is the way how duckweed grows, and we will be covering this one in detail when we go into duckweed production, and I will show you some of those live examples. Water instead discharging grows for duckweed cultivation, very similar type of tank, and you get a protein powder. And this duckweed contains almost 30 to 35% protein on dry basis, moisture content over 90%. It is a floating plant on the surfaces. How many of you have seen the lake with these green plants? Yeah? You have seen most of the lakes are always green, and they have one of those jetting system to collect all this thing and cleaning it, yeah. So, basically if that discharge water is going into river, you design a system, even open pond system or in a tubular system which grows duckweed within that, it will look nice, it will give a greener appeal, and then to discharge the water, and that is a perfect biomass, yeah. If you do a controlled production, or you can call it a controlled crime, that is organized crime or disorganized crime, yeah. So, that means how you can produce duckweed. This is the strategy for water, and now this is the figure, it shows what is the growth rate and crude protein content compared to oats, soybean, barley, maize, sorghum and duckweed. That means amount of protein produced per unit of land. If you have 1 hectare of land, how much plant protein can be produced in a year, yeah. You can take 2 crops or whatever, whereas if you have that much amount of land, how much duckweed protein you can produce, yeah. Here White is not talking about the food protein alone, but for feed protein. But if you look into the literature, duckweed is used extensively for human food application and is grown on the clean water for human food in Southeast Asia, and it has been already gained approval for human food application and commercially cultivated in America and certain countries in Europe. In Asia, India, we do not do that consumption production at the moment, whereas in China, Southeast Asia, this is carried out, and Israel is another country who does extensively this duckweed production, yeah. So, this is quite complicated matrix, yeah, and now this is being calculated based on seafood. 1, whatever side streams we get, what is it? Processed water and solid side stream, right? Solid side stream, what we can obtain? Protein, chitin and other nutrients, yeah. If this protein, fish meal, fish protein concentrate, isolate and hydrosolate, considering 40% of solid waste is used as protein rich meal, and this is amount of tons of protein which can be recovered from the European seafood production, yeah. Chitin, considering 15% of solid waste and 20% chitin purity, yeah, based on whatever process we do without using any new technique. Collagen, gelatin, hydroxyapatite, other day I was talking to you about hydroxyapatite or minerals which can be obtained. Is it readable from there, yeah? That is good. And then when it comes to processed water, protein, assume 7%, considering wash water for fillet, steaming, brining, mussels cooked water, well cooked water, everything take an average of 7. Minerals 2.5% weight by volume. Residual water, if you remove 70% of protein and 60% mineral recovery and other nutrients. Yeah. Now, when you recover some of those nutrients, and if you recover the protein based on the water usage, this is the ton of the protein what you can obtain, based is calculated based on 70% of protein recovery, which can replace 50% of soya protein which is imported from other countries into Europe. Yeah. This is just showing the business case how it can operate if we have valorized the waste. So, whatever we discuss, the implication of waste on greenhouse gas emissions or for dumping it, how this is, or how we can recover nutrient and what is the value of it. Recovered minerals, yeah, this many tons, considering 60% mineral. Collagen, gelatin, hydroxyapatite, again same thing from processed water, that also will contain some amount of protein which is having minerals and other element. We can obtain this type of ingredient. And very similar approach can be adopted for any given state in the country or whole of India. You know how much seafood is processed, what are the side streams obtained, whatever processes of recovery are there, different unit operations, and you can design this full strategy. Now, if this wastewater, residual water, is used for duckweed production alone, this much ton of biomass you can produce, this much ton of protein, and the protein will have 15% replacement of soya protein, at the same time solving your environmental issues. Yeah. Other one, microalgae production, this is calculated only for cholera vulgaris biomass. This much ton of cholera vulgaris biomass can be produced based on this particular wastewater and the protein which we can obtain. If you take simple protein extraction process which is 60% efficient, there how much protein we can obtain. Yeah. So, any of those ingredients, any of those ingredient using these processes to produce another biomass, we can have a fish feed to feed it to fish, because when you grow fish they need a feed. You make duckweed or microalgae to make a vegan product. Somebody is working on vegan meat product and vegan fish product, and same duckweed and microalgae or macroalgae will have similar smell as a fish. That is a perfect product for making vegan or meat alternative, or same this protein goes for non-vegan product, or chitosan or collagen can be used for making biodegradable packaging. Yeah. So, this was the crux of your solid waste and liquid waste, how this system can be generated. Yeah. So, this is like a city map. So, this like a Rome was not built in a day. Same way, to achieve this you cannot do it in one go. You need to have optimization to make duckweed production. Multiple number of theses and research has been carried out. Multiple number of theses will be covered to produce the microalgae, selection of species and all those things. Half of the work is already there in literature. You have to pick the best condition. Some of your colleagues and people are working on to the making of products out of it. Some are working on extractions. Yeah. So, all those informations comes together and to make a full process line. Yeah. You can put any specific material to it. Yeah. And if you have to simulate it, this is based on actually this should have been based on 100 kg, but this is on actual value. 100 kg how much you can obtain. Yeah. And then you can change the biomass and you can make this particular process. Yeah. So, I have been told to provide one assignment for you which will be evaluated. So, you will have to develop this type of scenario, yeah, and just put a reference to it, yeah, how much you can obtain different ingredients out of it. Yeah. So you can take a biomass of fish, yeah, A, B, you can have your dairy, yeah, C, based on your choice, yeah. I don't want to make non-vegetarian vegetarian, vegetarian as a non-vegetarian. Whatever is your choice of a crop, you can make a list of it. I can hand over to Ganga or to him and then complete your assignment, yeah. It's not difficult, it's very easy assignment, but whatever you are picking, you have to put a justification to it, yeah, or what is the source which shows how much protein it can be obtained, or what is the process, yeah, yeah. Is it easily done? So this was the valorization of liquid. So what did we study? What are the solid side stream, the liquid side stream? What are the valorization strategies, yeah. Now I will quickly go through this particular duckweed production maybe in the next lecture. So if you have your wastewater and if you have your process water and you have your solid side streams, yeah. Do you have any question related to this, how you can process it or how you can valorize it, or if you have any suggestion? Are you more confused? Because as we go along, confusion level might increase, yeah. Because there is a lot of thinking process what you guys have to do to establish the processes. This is a bigger picture and specific processes for extraction of proteins, protein extraction, lipid extraction, chitin, chitosan, minerals. All these things will be specifically covered on how we extract those, yeah. Any questions?
Sir, I have a very simple query. With this previous things, the end thing is the duckweed, it is coming as a feed which is in place of soy, we will go for the cattle feed. My simple query is that if it is having, right now you included that it will be used for the vegan fish product as well. We can like that product. We know how the fish has a smell. Similar to that, it will be having a smell. But do the cattles will they eat that kind of smell if that is carrying the duck?
No, they do, because actually that's a very valid question. And here duckweed is used as a source of protein. That means you obtain a protein from duckweed. And duckweed, which we'll cover in the next lecture, duckweed production system. Duckweed basically contains majority of the water soluble protein called rubisco, like a green grass. It's having a cellulose, starch and everything. So that protein is extracted and it is consumed. A. Second one, it's duckweed itself will not have a fishy smell, yeah. That is used as a feed. So that means then you have your, again veterinarians are required to do the feed formulation, because feed formulation is equally complicated than as a food, because feed should have not only the protein is the major ingredient, plus you have all of the minerals and nutrients are added in to make a animal feed, yeah. So that is that's another question which is used for feeding purpose. A. B. Duckweed also, if it is not for animal feed, it is also for fish feed, which the fish automatically they consume in the water when those type of aquatic plants are growing, yeah. Because we don't feed anything in the ocean, do we? In river fish is there, what they get a food from? all the small plants, small insects and all those things growing around. Yeah, this is the purpose how we can solve the two problems. One is the environment one, to valorize the wastewater and recover that nitrogen, which is at the end of the day is going to go into this form of sludge, adding to the landfill or go into the river water and disturbs the ecosystem. This whole story is balancing between 3 E's. What were the 3 E's? Economy, environment and ecosystem. Yeah. So these are the questions what you need to answer, and that's very valid question. Yeah, I can propose what you should eat, what will be healthy. Yeah, but you will eat based on your own choices. Yeah, even if I know egg is very healthy, being a vegetarian I won't eat it. Yeah, so there it comes social aspect. Yeah, right. So that's why we all are different. Everybody is having different eating habits, and if everybody want to eat only the same type of food, then it's a problem. Yeah. So we all have different eating habit because all are different. That's the saying, all 5 fingers are of different sizes. If all 5 fingers are of the same size, we can't do any job, right? Any other question? I thought dairy technologists might be happy having that dairy example. Yeah. No other questions? So, who is going to summarize what we did today? Anyone? Will get plus 10% marks. The lady in the last will do it.
Firstly, you sir, you give the recap of the yesterday class. After that, you explain just example of shrimp culture. After that, solid side
streams. Yeah.
Yes, sir. Solid side stream valorization, liquid side valorization, and after that give the example of fish culture and how to estimate different proteins and lipids, and overall introduction of overall the map idea of the research, like sir, how to produce from substrate to like production level, and how to consume, and
okay.
Yes.
That's good. So at least I can say 10% success is there anyway. Yeah. So that's good. So basically again was the solid side stream and liquid side stream, what are the biomasses. Yeah. And if you are interested in having the specific research paper, not research, review paper which clearly explain all those things, I can easily provide you with. Yeah. And any of the questions, if you cannot ask here, you can ask after, and whenever we have interaction, you can ask all those questions, how we can grow microalgae and duckweed, because it will be difficult to do all the practicals of growth in, but we have carried out that. You will see that example from the duckweed itself. At the end, when you see the phytotowel one, it was a project, is a BSIC Bioeconomy Student Innovation Challenge that was done at European level. Every country was sending one team. One team went from Ireland, and they got second prize for this particular concept. Yeah, and this concept is not rocket science, and that was carried out by one PhD. Her PhD was on the food processing, on macroalgae production and valorization, where her basic degree was in entomology. completely different area. Bachelor's in zoology, master's in entomology, and PhD on food production. Yeah. So that means food science is not a domain of a specific food scientist. If you think we have done BSc food science, MSc food science will do wonders there. That's not always true. Yeah. So it's all again how you think about a different area and club it together with a process. That one you will see which will make you more innovative way of thinking how you can produce a duckweed. And the duckweed was grown in a lab, and then if you go fine tuning of improving the performance or improving the production efficiency, that comes secondary. Yeah. So that's great. If you don't have any questions, so we'll close it at this point, and we'll meet again for the next lecture.